Good morning, dear students. I welcome you all to this course on integrated circuits. First of all, let me introduce myself. Myself, Dr. Kiran Sonone from the Electronics and Telecommunication Department at R.C. Patel Institute of Technology, Shirpur. I have more than 20 years of teaching experience in engineering education. In this course, we will study the fundamentals and applications of integrated circuits, which play a very important role in modern electronic systems. Vision of the institute to become a leading institute in technical education, fostering innovations, research, ethical values, and sustainable development for the betterment of society. Mission of the institute to impart high quality technical education through innovative and interactive learning process and high quality globally recognized instructional programs, fostering a collaborative scientific temper among students with ethical responsibility towards the society, preparing students from diverse backgrounds to have aptitude for employment, entrepreneurship, and research with a spirit of professionalism. Vision of the department to produce competent electronics and telecommunication engineers with a commitment to serve society. Mission of the department deliver innovative ICT enabled and interactive learning fostering excellence in electronics and telecommunication engineering, cultivate scientific inquiry, ethical responsibility, and collaboration to address societal and technological challenges effectively, empower diverse students with skills for employment, entrepreneurship, and research, nurturing professionalism and lifelong learning. Today we are going to discuss about the zero crossing detector, that is called as a ZCD. A zero crossing detector or ZCD is one type of voltage comparator used to detect a sine waveform transition from positive and negative that coincide with the input crosses the zero voltage condition. An op-amp detector that has the ability to detect the change from positive to negative or negative to a positive level of sinusoidal waveform is known as a zero crossing detector. A zero crossing detector is a comparator with the reference level set at zero. It is used for detecting the zero crossing of AC signal. Zero crossing detector detects how many times the input signal cross the zero value or zero voltage level. Zero cross detector is basically a comparator circuit that compares the input sinusoidal signal or sine wave signal with the zero voltage level. In other words, we can say that this detects the voltage changing from positive level to negative level and negative level to positive level. The output of the zero cross detector changes when the input voltage crosses the zero level to high or high to low. So this is a circuit diagram for the zero crossing detector here. So first we discuss about the inverted zero crossing detector. The input is given to the inverting terminal of this comparator here, and at non-inverting terminal the reference voltage is 0, that is directly connected to the ground terminal here. So depending upon the difference in between the inverting and non-inverting terminal, it gives you output here. So whenever the difference voltage is less than 0, that time the output is at plus V saturation, and whenever a difference voltage is greater than 0, that time the output is minus V saturation. Now we discuss about the non-inverted zero crossing detector. Now the input is given to the non-inverting terminal and the reference voltage, that is 0 volt, is connected to the inverting terminal. So this inverting terminal is connected to the ground, and depending upon the difference voltage it gives you output either plus V saturation or minus V saturation. So this saturation voltage is approximately is equal to the power supply voltage. Whenever the difference voltage is greater than 0, then the output is plus V saturation, and whenever the difference voltage is less than 0, then the output is minus V saturation. So in this inverted ZCD means the input is given to the inverting terminal and the reference 0 volt is given to the non-inverting terminal. Here we can see here the output here. So basically our input is in terms of the sinusoidal signal, and whatever the output we got, so whenever the difference voltage is less than 0, output is plus V saturation, and whenever the difference voltage is greater than 0, that time the output is minus V saturation. So at output we got a square wave according to the difference in between the inverting and non-inverting terminal here. So we can see this input and output waveform. Thank you.